In the spring of 1900, a Greek sponge diver looked into the Mediterranean Sea and believed he had found a graveyard. Human bodies appeared scattered across the ocean floor. Some seemed to be lying on their backs. Others looked frozen where they had fallen. One appeared to be staring directly at him through the dark water. The diver's name was Elias Stadiates, and within a few minutes, he would make a discovery that would eventually force historians to rethink what ancient technology was capable of. But that wasn't what frightened him. What frightened him was the possibility that he had stumbled into a place no living person was meant to see. 45 meters beneath the surface, surrounded by silence and darkness, Elias could barely make out the shapes below him. The deeper he looked, the more figures emerged, dozens of them, perhaps more. His pulse began racing. Inside his heavy copper diving helmet, he yanked hard on the signal line connected to the ship above. Once, twice, again. The crew immediately began pulling him toward the surface. Something was terribly wrong. At least, that's what he believed. What he didn't know was that the terrifying sight beneath him would eventually uncover one of the most important technological mysteries in human history. A mystery involving lost knowledge, ancient engineers, forgotten workshops, and a machine so extraordinary that some scientists would later compare its discovery to finding a modern computer in the ruins of the ancient world. Before we continue, I'd love to know where you're watching from and what time it is there right now. History has a way of connecting people across continents and generations, and it's always fascinating to see where these stories are reaching. And if you enjoy forgotten mysteries, remarkable discoveries, and real stories from the past, consider subscribing. There are many more journeys like this ahead. At the time, Elias wasn't searching for history. He wasn't searching for treasure. He certainly wasn't searching for a machine that would puzzle scientists for more than a century. He was simply trying to make a living. Born on the Greek island of Symi, Elias belonged to a community famous for sponge diving. The work was dangerous, the pay was uncertain, and every trip carried risks that modern divers rarely have to think about. Divers descended wearing massive copper helmets connected to the surface by air hoses. The suits were heavy. Movement was slow. Visibility was often poor. A damaged airline or sudden problem underwater could quickly become fatal. But for men like Elias, the sea was both employer and enemy. It fed families, paid debts, and sometimes claimed lives. In early 1900, Elias and his crew were sailing across the Mediterranean searching for sponge beds when a powerful storm changed everything. The weather became too dangerous to continue. The captain was forced to alter course and seek shelter near a small rocky island called Antikythera. At the time, few people outside Greece had ever heard of it. It sat quietly between Crete and mainland Greece. Remote, windswept, forgettable, or so it seemed. As the storm weakened, the crew decided to make use of the delay. Rather than sit idle, they would search nearby waters for sponges before resuming their journey. It was an ordinary decision, the kind made by working men every day. Nobody aboard the vessel suspected that history was waiting beneath them. When Elias made his descent, sunlight gradually disappeared above him. The deeper he went, the colder the water became. The world narrowed to darkness, breathing, and the faint glow filtering through the sea. Then he saw them, shapes, large shapes, human shapes. One appeared to be lying on its side. Another seemed collapsed face first against the seabed. Several looked almost intact, as if they had fallen only recently. The scene felt wrong, unnatural, like discovering a battlefield forgotten by time. Yet something about the figures bothered him even more. They weren't drifting. They weren't moving. They seemed frozen, locked in place, waiting. When Elias reached the surface and recovered from the shock, another dive was organized. This time he forced himself to look more carefully, and within moments everything changed. The bodies weren't bodies at all. They were statues, bronze statues, marble statues, some larger than life-size, scattered across the remains of an enormous ancient shipwreck. The realization stunned the entire crew. Ancient artifacts beneath the sea weren't unheard of, but nothing like this. Not on this scale, not with treasures visible everywhere. Word spread quickly. Soon Greek authorities became involved. Archaeologists arrived. Recovery operations began, and each new dive revealed something even more remarkable. Massive statues emerged from the sea. Jewelry, coins, luxury glassware, exquisite artworks. Objects that had remained hidden beneath the Mediterranean for nearly 2,000 years. Newspapers reported the discovery. Museums prepared to receive the artifacts. The shipwreck was rapidly becoming one of the greatest archaeological finds of its era. But hidden among all those spectacular treasures was something nobody paid much attention to. It wasn't beautiful. It wasn't valuable. And it certainly wasn't impressive. It looked like a broken lump of bronze, corroded, crusted with minerals, damaged beyond recognition. Compared to the statues, it seemed worthless. Compared to the jewelry, it looked like scrap metal. Museum workers stored it away with hundreds of other recovered objects. Few people gave it a second thought, and for a while, that seemed perfectly reasonable, because nobody looking at those fragments could have imagined what was hidden inside them. Yet that neglected piece of bronze would eventually raise a question far more astonishing than the shipwreck itself. Not who owned the cargo, not where the ship was sailing, but how ancient people managed to build something that appeared centuries ahead of its time. And the answer to that question began with a single, tiny gear tooth hidden beneath layers of corrosion, a detail so small that most people would have missed it entirely. But once it was noticed, the entire mystery changed. For 2 years, the strange bronze fragments sat quietly inside a museum. Visitors walked past them. Researchers focused on the statues. Newspapers celebrated the treasures recovered from the sea, and the mystery remained hidden. Had events unfolded slightly differently, the story might have ended there. The statues would have become famous. The shipwreck would have entered archaeological history, and the broken bronze fragments would have remained nothing more than forgotten debris from an ancient disaster. But in 1902, a man named Valerio Stais noticed something unusual. Stais was examining artifacts recovered from the wreck when his attention settled on one of the corroded bronze pieces. At first glance, it looked no different from the others. Damaged, broken, covered in centuries of corrosion. Yet something caught his eye, a tiny row of teeth, perfectly shaped, perfectly spaced. The teeth of a gear. At first, that discovery created more confusion than excitement. Ancient Greek artifacts often contained decorative patterns, curved designs, geometric shapes, artistic details, but these weren't decorations. They were mechanical, deliberate, engineered. And if they truly belonged to a gear, then the harmless-looking lump of bronze from the shipwreck was not a piece of scrap metal at all. It was part of a machine. That realization immediately raised a troubling question. What kind of machine? Because according to everything historians believed at the time, ancient civilizations were not supposed to possess technology this sophisticated. They built magnificent temples, created extraordinary sculptures, made important advances in mathematics and astronomy. But precision gear systems belonged to much later periods of history, or so everyone thought. The fragments were studied more carefully. Then another gear appeared, then another, then another. The deeper researchers looked, the more complicated the object became. Soon it was clear they weren't looking at a single gear. They were looking at an entire system, dozens of interconnected components, each designed to interact with the others, each serving a purpose. The discovery transformed the bronze fragments from a curiosity into a mystery. And not just an archaeological mystery, a historical one, because machines like this don't appear out of nowhere. Complex technology usually has ancestors, earlier versions, failed attempts, workshops, teachers, craftsmen passing knowledge from one generation to the next. Yet historians had never found anything quite like it. No earlier examples, no competing versions, no obvious technological family tree, just one machine, one shipwreck, one survivor, And that created a bigger question. If ancient engineers built this device, what else had they built? Suddenly, the mystery was no longer about a single artifact. It was about an entire world that seemed to be missing. A world of metal workers capable of cutting precision gears. A world of astronomers capable of understanding complex celestial cycles. A world of teachers and students exchanging ideas sophisticated enough to become machinery. Somewhere, long before the ship sank, those people had existed. The machine proved it. The problem was finding them. Years passed, then decades. Researchers proposed theory after theory. Some believed the device helped sailors navigate. Others thought it tracked calendars. A few suggested it might have been some kind of astronomical instrument, but nobody could prove anything. The fragments refused to give up their secrets. Then technology began helping historians ask better questions. As X-ray imaging improved, researchers could finally look inside the corroded bronze without damaging it. And what they discovered changed everything. More gears, far more gears than anyone expected. Not a handful, dozens. An intricate network hidden beneath centuries of corrosion. The machine was becoming more sophisticated with every new examination. And the gears themselves seemed to be doing something extraordinary. They weren't measuring distance. They weren't tracking money. They weren't keeping time in the way researchers initially suspected. Instead, certain gear ratios appeared to correspond to something far larger, something ancient civilizations had spent centuries studying. The heavens, the sun, the moon, the repeating patterns of the sky. And if that interpretation was correct, then the machine recovered from the Antikythera shipwreck wasn't merely an ancient device. It was something much more remarkable. A machine designed to model the universe itself, which immediately raised another question. Who would need such a machine? And perhaps even more intriguing, who was capable of building one? The machine shouldn't have existed. That was the conclusion many researchers kept returning to. Not because it was impossible, because it seemed to arrive in history fully formed. Imagine discovering a modern watch buried in an ancient ruin. Your first question wouldn't be how the watch worked. It would be, where did it come from? Who taught someone to build it? What industry existed behind it? The Antikythera mechanism created exactly that problem. By the middle of the 20th century, researchers were becoming increasingly convinced that the device wasn't just an ancient instrument. It was evidence. Evidence of a level of scientific and engineering knowledge that history had only partially remembered. And whenever historians followed that trail, one name kept appearing: Archimedes. More than 2,000 years before modern computers, Archimedes had already become famous for combining mathematics with machinery. Ancient writers described devices capable of lifting enormous weights, machines designed to defend cities, mechanical systems so ingenious that later generations often struggled to understand how they worked. Some accounts even described astronomical devices capable of modeling the heavens. For centuries, many historians treated those descriptions cautiously. Ancient writers loved great stories, and great stories often became exaggerated. But now there was a problem. The Antikythera mechanism had proven that at least some of those stories were plausible, because someone really had built a machine capable of modeling the sky, not as a metaphor, not as a legend, as a physical object made of bronze gears. To understand why that mattered, researchers had to step back and look at the world that produced it. The ancient Mediterranean wasn't isolated. Ideas traveled constantly. Merchants carried knowledge alongside cargo. Students studied under famous teachers and carried those lessons across continents. Astronomers shared observations. Mathematicians refined calculations. Engineers experimented with mechanical solutions. The mechanism appeared to be the product of that environment, not a miracle, not an accident, the result of generations building upon generations of knowledge. And the more researchers learned about the machine, the clearer that became. One section tracked the phases of the moon, another predicted eclipses. Yet another followed a cycle nearly 19 years long. Each function required careful observation of the sky, not months of observation, generations. Someone had spent decades recording celestial events. Someone had identified repeating patterns. Someone had transformed those patterns into mathematics. And eventually, someone transformed that mathematics into machinery. The machine was becoming less mysterious, but the people behind it were becoming more mysterious, because every answer pointed toward a larger world hiding behind the artifact, a world of workshops, teachers, apprentices, engineers, real people solving real problems. Yet historians couldn't find that world. No surviving workshop, no unfinished mechanisms, no collection of spare gears, nothing. It was as if the machine had somehow outlived the civilization that created it. Then researchers made another discovery, and this one brought them closer to the builders than ever before. Using advanced imaging technology, scientists began examining the interior surfaces of the fragments. At first, they were searching for mechanical details. Instead, they found writing, thousands of tiny Greek characters, some so small they could barely be seen with the naked eye. Hidden beneath centuries of corrosion were inscriptions left behind by the people who built the machine. For the first time, researchers weren't just studying the mechanism. They were hearing the faint echoes of its creators. The inscriptions acted almost like an instruction manual. Labels identified displays. Descriptions explained cycles. Guidance helped users understand what they were seeing. And that discovery changed something important. Because suddenly, the machine didn't feel like a secret device created for a handful of experts. It felt like something designed to be used, to teach, to demonstrate, to explain. Someone expected another person to interact with it. Someone expected knowledge to be shared. That raised another fascinating question. Who was the audience? A wealthy collector, a scholar, a teacher, a politician, an aspiring astronomer? Nobody knows, but whoever owned the machine possessed something extraordinary. A device capable of turning centuries of astronomical knowledge into moving gears. And somewhere long ago, someone was waiting for it. Because the mechanism hadn't been discovered in a workshop, or a library, or an observatory. It had been found aboard a ship carrying luxury goods across the Mediterranean, a ship that never reached its destination, which means the machine was traveling somewhere. It had a destination, an owner, a future. Then a storm arrived. The ship sank, and one of the most sophisticated machines in the ancient world disappeared beneath the sea for nearly 2,000 years. But the greatest surprise was still ahead. Because once researchers decoded more of the inscriptions, they realized the machine wasn't merely tracking the sun and moon. It may have been doing something even more astonishing. Something that suggested the builders understood the universe at a level few people had ever imagined. The sky looks simple when you glance at it. The sun rises. The moon changes shape. The stars drift across the darkness. For most of human history, that seemed mysterious enough. But the builders of the Antikythera mechanism weren't satisfied with simply watching the heavens. They wanted to understand them, and more importantly, they wanted to predict them. As researchers continued decoding the inscriptions hidden inside the machine, they discovered something remarkable. The device wasn't just showing astronomical events. It was explaining why they happened. Certain markings identified eclipse cycles. Others described celestial patterns known only to experienced astronomers. The machine functioned almost like a textbook made of bronze. Turn a handle, watch the gears move, see the universe unfold. And suddenly, a much larger story began emerging. Because machines like this don't appear in societies that ignore science. They appear in societies that value it. Somewhere in the ancient Mediterranean, there must have been people spending years studying the heavens, teachers explaining planetary motion, students learning mathematical cycles, engineers experimenting with ways to turn knowledge into machinery. The Antikythera mechanism was beginning to look less like an invention and more like the surviving piece of an entire scientific culture. Then came one of the biggest surprises of all. Researchers found evidence suggesting the machine may have tracked the 5 planets visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. Today that might not sound extraordinary, but imagine the challenge facing an ancient engineer. Each planet moves differently. Each follows its own pattern. Sometimes they appear to move backward through the sky, sometimes forward. Their motions confused observers for centuries. Yet someone may have found a way to represent all of them inside a single mechanical system. If true, the mechanism wasn't merely predicting eclipses. It was modeling almost the entire known cosmos. That realization stunned many historians, because suddenly the machine wasn't comparable to a clock. It was comparable to a miniature universe. And if ancient engineers could build something like that, then the obvious question returned once again. Why have we only found one? The question haunted researchers because technology rarely leaves behind a single survivor. Think about any major invention. Printing presses, telescopes, steam engines, computers, they spread, they evolve, they inspire new versions. The Antikythera mechanism seemed different. One machine, one shipwreck, one surviving example. At least that's what history had given us so far. But another possibility was beginning to emerge. Maybe the machine wasn't unique. Maybe it was simply lucky enough to survive. Because ancient writers occasionally mentioned mechanical models of the heavens, astronomical devices, moving representations of celestial motion. For years, those references were treated as interesting curiosities. Now they looked like clues. Perhaps other mechanisms once existed. Perhaps dozens existed. Perhaps hundreds. The problem was survival. Bronze was valuable, extremely valuable. Ancient societies rarely threw it away. Broken objects were melted down. Old machinery became raw material. Damaged devices disappeared into furnaces. Generation after generation. The Antikythera mechanism escaped that fate for one reason. A ship sank before anyone could recycle it. In a strange twist, disaster preserved history. And that realization changed how researchers viewed the entire discovery. The machine wasn't necessarily the peak of ancient engineering. It might simply be the only surviving witness. A survivor speaking for countless lost inventions. That idea carried an emotional weight of its own, because somewhere there may have been workshops filled with devices like this. Students learning from them. Teachers demonstrating celestial cycles, engineers refining designs, entire traditions of knowledge that vanished without leaving physical traces. The machine wasn't only telling us what ancient people knew, it was reminding us how much has been lost. Then researchers turned their attention back to the ship itself, and what they found raised yet another mystery. The cargo wasn't ordinary. The vessel carried luxury goods worth enormous sums. Fine statues, expensive glassware, prestigious artworks. Everything about the ship suggested wealth and influence, which made historians wonder, what role did the mechanism play among such treasures? Was it simply another valuable object, or was it one of the most precious items aboard? Because unlike statues, the machine represented something harder to measure: knowledge, specialized knowledge. The kind that takes generations to develop. Somewhere, someone had invested years creating it. Somewhere, someone expected it to arrive. Then the ship disappeared. The owner disappeared. The destination disappeared. And with them vanished one of the greatest technological achievements of the ancient world, for nearly 2,000 years, until a frightened sponge diver accidentally found it. But even after everything researchers had learned, one mystery remained larger than all the others. Not the machine, not the ship, not the owner, the people who built it. Because the closer historians looked, the clearer it became that the Antikythera mechanism wasn't the story of a single invention. It was the story of a lost world of knowledge. And that world was proving far more fascinating than anyone had imagined. Somewhere in the ancient Mediterranean, A craftsman sat at a workbench and cut the first gear. Then another, and another. Each tooth had to be shaped with extraordinary precision, not because perfection was desirable, because without it the machine wouldn't work. That simple reality may be the most astonishing part of the Antikythera story, not the shipwreck, not the discovery, the people, because machines like this do not appear by accident. They require knowledge, training, experience, and most importantly, they require communities. Think about any modern technology. No one builds a spacecraft alone. No one creates a computer industry from scratch. Complex achievements emerge when generations build upon the work of those who came before. The Antikythera mechanism suggests exactly that kind of world once existed. A world historians are still trying to reconstruct, and the more researchers searched for it, the more frustrating the mystery became, because they could see the final product, but they couldn't find the workshop, no abandoned factory, no unfinished mechanisms, no collection of spare gears, nothing. It was as if the machine had survived while the world that created it vanished completely. One possibility led historians toward the Greek island of Rhodes. In the ancient world, Rhodes was famous for astronomy, mathematics, and engineering. Some of the Mediterranean's greatest thinkers studied there. The island was known for scientific innovation. If a place existed capable of producing a machine like the Antikythera mechanism, Rhodes was a strong candidate. But there was a problem: evidence. Theories were plentiful, proof was scarce. No workshop has ever been identified with certainty. No document explicitly states where the machine was built, and so the search continued. Yet even without a workshop, clues kept appearing. Ancient writers occasionally described mechanical models of the heavens, devices that could demonstrate planetary motion, machines designed to teach astronomy. For centuries, many historians treated these accounts cautiously. Now they seemed much harder to dismiss. Because the Antikythera mechanism had proven such devices were possible, the ancient authors weren't describing fantasies. They were describing a technological world that had largely disappeared, and that realization changed the emotional center of the story. For years, the mystery had focused on what the machine could do. Now attention shifted toward what humanity had lost, because history is not simply a collection of discoveries. It's also a collection of disappearances. Libraries burn, buildings collapse, skills fade, knowledge vanishes, sometimes slowly, sometimes suddenly. Imagine a teacher who never finds a student, a workshop that closes during a war, a manuscript destroyed by accident. One missing link may not seem important, but over centuries, enough missing links can erase entire traditions. The Antikythera mechanism feels haunting because it survived when so much else didn't. It gives us a glimpse of a chapter that almost disappeared completely. And researchers began wondering how many other chapters suffered the same fate. How many inventions vanished before anyone recorded them? How many scientific instruments were melted down for scrap metal? How many breakthroughs were forgotten because no surviving copy remained? The machine was no longer an isolated artifact. It had become evidence. Evidence that the ancient world was probably more technologically sophisticated than the surviving record suggests. And then another discovery deepened the mystery even further. When researchers analyzed the inscriptions more carefully, they noticed something revealing. The writing wasn't aimed solely at experts. It explained things, guided users, identified displays. The machine seemed designed to teach. That detail carried enormous implications, because educational tools require audiences. Audiences require demand. Demand suggests production, and production suggests that devices like this may not have been as rare as historians once assumed. Perhaps wealthy scholars owned them. Perhaps teachers demonstrated them. Perhaps students learned from them. Perhaps somewhere in the ancient world, watching the gears move was as fascinating as watching a modern planetarium today. Suddenly the machine felt alive again, not as an archaeological artifact, as an object people actually used. People turned its handles, read its inscriptions, studied its displays, asked questions about the sky. And somewhere among those people was the last person to touch it before the shipwreck. The last owner, the last observer, the last person who watched the gears move. Then a storm arrived, the ship sank, and that entire world slipped beneath the sea for nearly 2,000 years. Yet perhaps the most remarkable thing is that the machine still succeeded, not in reaching its destination, but in doing something its builders could never have imagined. It carried their knowledge across 20 centuries, and in doing so, it delivered a message that historians are still trying to fully understand. Because the Antikythera mechanism doesn't just tell us what ancient people knew, it forces us to ask what else they knew. And that question may be the most important mystery of all, because if one extraordinary machine survived by chance, how many others are still waiting to be found? More than a century has passed since Elias Stadiades surfaced in panic, convinced he had discovered a graveyard beneath the Mediterranean. Yet the story he accidentally began is still unfolding. Most archaeological discoveries eventually settle into certainty. Questions get answered, debates fade, the evidence becomes clear. The Antikythera mechanism refused to follow that path. Every answer seemed to create another mystery. Researchers learned what the machine did, then wondered who built it. They discovered how it worked, then wondered where the technology came from. They decoded its inscriptions, then began asking how much ancient knowledge had disappeared. The deeper they looked, the larger the story became. And perhaps the biggest surprise was waiting beneath the sea itself. For decades, people assumed the wreck had already given up its secrets. After all, divers had recovered statues, jewelry, glassware, coins, and the mechanism itself. What more could possibly remain? Then modern technology arrived. Unlike the sponge divers of 1900, modern archaeologists could map the seabed in extraordinary detail. Robotic systems explored areas that earlier divers couldn't safely reach. High-resolution imaging revealed objects hidden beneath sediment. And almost immediately, researchers realized something astonishing. The original recovery teams had found only part of the wreck. Artifacts still remained scattered across the seabed. Bronze objects, pieces of statues, luxury goods, evidence that the ancient ship was even larger and more important than historians once believed. That discovery carried an exciting implication. If so many artifacts remained undiscovered for more than a century, what else might still be down there? The possibility captured imaginations around the world, because everyone was thinking the same thing. What if there are more pieces of the mechanism, or even another mechanism entirely? For archaeologists, that possibility was almost irresistible, not because another machine would be valuable, because it would answer questions that historians have debated for generations. A second mechanism would immediately prove the Antikythera device wasn't unique. A third would transform ancient technology overnight. And somewhere beneath the excitement was a deeply human reason for continuing the search. People wanted to meet the builders, not literally, but through their work. Every new fragment is a conversation across time. Every inscription is a voice from a vanished world. Every discovery brings researchers one step closer to understanding the people behind the machine. Because ultimately, the gears are not the real mystery. The real mystery is human ingenuity. Imagine living in a world without electricity, without telescopes, without modern engineering tools. Then imagine studying the sky so carefully that you discover repeating cycles invisible to most people. Imagine spending years transforming those observations into mathematics, then transforming that mathematics into machinery. That is what someone accomplished. A real person, with real tools, in the ancient world. And perhaps that's why the Antikythera mechanism continues to fascinate people far beyond archaeology. The machine challenges assumptions, not about technology, about people. We often imagine ourselves standing at the peak of knowledge, looking back at simpler generations. The mechanism reminds us that intelligence has never belonged to a single era. Curiosity has never belonged to a single civilization. The desire to understand the universe is timeless. 2,000 years ago, someone looked at the heavens and asked questions. Questions about the moon, questions about eclipses, questions about time itself. Then they built a machine to explore those questions. Centuries later, another group of people discovered that machine and began asking questions of their own. In a strange way, the story comes full circle. Ancient engineers trying to understand the cosmos, modern historians trying to understand them, both searching for answers, both following clues, both driven by curiosity. And somewhere between those two worlds sits the Antikythera mechanism, a bridge across time, a reminder that knowledge is never truly lost as long as someone keeps looking for it. But one final mystery still remains, the most important mystery of all, because even after everything researchers have learned, they still cannot answer a simple question with certainty. What happened to the world that created this machine? How does a civilization capable of building something so extraordinary leave behind so little evidence of the tradition itself? The answer may tell us as much about history as the mechanism ever could, and it forces us to confront a truth that is both fascinating and unsettling. History isn't just a story of discoveries. It's also a story of things forgotten. When Elias Stadiades climbed back onto the deck of his ship in the spring of 1900, he believed he had witnessed something terrifying. Bodies on the seafloor, human figures frozen beneath the Mediterranean, a sight so unsettling that he immediately signaled to be pulled back to the surface. What he couldn't possibly know was that his discovery would still be changing history more than a century later. Most archaeological discoveries answer questions. The Antikythera mechanism did the opposite. Every answer uncovered a larger mystery. At first, archaeologists found a shipwreck. Then they found statues. Then a strange machine. Then they discovered that machine could predict eclipses, track celestial cycles, and model the movements of the heavens. And with each revelation, the ancient world became a little larger than it had seemed before. But perhaps the greatest discovery wasn't the machine itself. It was what the machine implied. Somewhere in the ancient Mediterranean, there were people capable of building this device. People who studied the sky with extraordinary patience. People who transformed mathematics into machinery. People who understood relationships hidden within the movement of the sun, moon, and planets. For centuries, many of those people were forgotten. The mechanism became their surviving voice. A voice preserved by accident. Because the truth is, the machine was never supposed to survive. It wasn't built as a museum piece. It wasn't built to impress future generations. It was built to be used. To teach, to calculate, to help people understand the universe around them. The fact that we can study it today is the result of an almost impossible chain of events. A ship sinks. The sea protects what time normally destroys. A storm pushes sponge divers off course nearly 2,000 years later. One diver descends into the darkness. And history gets a second chance. That realization carries an important lesson. The past is not a completed story. It's an unfinished investigation. For every artifact we discover, countless others may have vanished. For every surviving clue, entire chapters may still be missing. The Antikythera mechanism reminds us how much can be lost. But it also reminds us how much can still be found. Because even now, researchers continue studying the fragments. Marine archaeologists continue exploring the wreck. New technologies continue revealing details hidden inside the corroded bronze. And every new discovery brings us a little closer to understanding the people behind the machine. Not the artifact. The people. The engineer who cut the gears. The astronomer who recorded the observations. The teacher who explained the cycles. the owner who carried it aboard the ship, the minds that turned curiosity into knowledge. In the end, that may be why the Antikythera mechanism continues to fascinate the world. Not because it is mysterious, not because it is ancient, but because it feels familiar. The builders were asking the same questions we still ask today. How does the universe work? Can patterns be understood? Can knowledge be preserved? Can the unknown become known? Those questions connect us across 20 centuries. And in a strange way, the mechanism itself became the answer. A machine built to understand time that survived time. A machine built to explain the heavens that ended up revealing something equally important about humanity. Our curiosity, our creativity, and our refusal to stop searching for answers. Before we go, I'd love to hear your thoughts. What fascinates you most about the Antikythera mechanism? The engineering, the astronomy, the lost world that created it, or the possibility that other forgotten discoveries are still waiting beneath the sea? Leave your thoughts in the comments below. And if you enjoyed this journey into one of history's greatest mysteries, don't forget to subscribe and join us for more stories from the forgotten